Hello students, welcome back to another video of MATHIPHY. In today's video, we will do question number 1 till 6 of paper 4, course code 0625. It's month May, June, year 2025, variant 1. Question number 1 says, circle the vector quantities in the list. So considering all these, acceleration is the quantity that has both magnitude and direction. So it is a vector quantity. Mass is only concerned with magnitude. Speed is also concerned with magnitude, not the direction. Time is also concerned with magnitude only, but velocity is concerned with magnitude and direction. So these both are vector quantities. B part of the question says, figure 1.1 shows the speed time graph for a train traveling from station A to station B. Part 1 says, state the maximum speed of the train. So if we see the graph, the maximum speed that the train achieves is this. In y-axis, one small box is representing 1 meter per second of speed. That means this value over here is 56 meter per second. So it is the maximum speed achieved by the train. Second part says describe the motion of train from station A to station B. So firstly, from this point till this point, this is a tilted straight line. And when we see our velocity time graph, a line like this shows increasing velocity and acceleration is constant. So I'll write increasing velocity and acceleration is constant. From this point till here, it is a straight horizontal line, and in velocity time graph information, straight horizontal line shows velocity is constant and acceleration is 0. So over here, velocity is constant and acceleration is 0. From this point till the point here, if we see the velocity time graph information, a negative gradient line represents that velocity is decreasing and deceleration is constant. So I'll write this over here. The velocity is decreasing and deceleration is constant. Writing all the information over here as well. For first line, speed is increasing and the train is accelerating. For second line, speed is constant, acceleration is 0. And for the third line, speed is decreasing and train is deaccelerating. Third part of the question says, calculate the distance between the station A and B. In this velocity time graph, distance is calculated by calculating the area under the graph. So if we see from station A to station B, this blue region is the area under the graph, and this shape is a shape called trapezium. To get the area of trapezium, we use the formula 1 by 2 into sum of parallel side times height. And if we see which sides are parallel in this trapezium, this straight line is parallel to this above straight line. So these are our A and B. To get the values of A and B, let me be clear that one small box over here is representing 10 seconds. So first parallel length is 530 seconds long, and the other parallel length, which is from this point to this point, is 400 seconds long. And what about the height of the trapezium? This straight line will tell us the height of trapezium, which is 56 meter per second. Solving this, the area would be 26040, and to two significant figure it would be 26,000. So the distance is 26,000 meter, and I'm writing it over here as well. Or we can also say that it is 26 kilometer. Now part number 4 says, on a different day the train takes 650 seconds to travel from station A to B. Suggest one change to the motion of the train that lead to this longer journey time. If they are asking for the motion, that means they are asking for velocity or acceleration. What happened to the velocity and acceleration that causes the time to delay? So we can say that the train have got less value of constant velocity than 56 meter per second. Question number 2 says a resultant force is applied to an object moving with the velocity v in a straight line. First part says state two different changes to the motion that the resultant force may cause. So again, if they're asking for motion, they're asking for velocity or acceleration change in these both. So something is moving and we apply force, it can change the direction of the motion or it can change the magnitude of velocity, and thirdly it can accelerate or deaccelerate the body. Second part says state one other way that the force may change a stationary object. So a force can change the size and shape of a stationary object. B part says describe how a uniform meter ruler, a pivot, and selection of masses can demonstrate that there is no resultant moment on an object in equilibrium. You may include a label diagram in your answer. So let's suppose that I have taken a meter ruler and I have placed a pivot on center of gravity of that meter ruler, or exactly at center of that meter ruler, and I have placed two masses on each side of meter ruler. Then I calculate the moment of these boxes by the formula of moment, which is force multiplied by perpendicular distance from the pivot. And if this is in equilibrium, the clockwise moment and the anti-clockwise moment will both be equal. So these are the steps for it. Firstly, we'll place a pivot at center of the meter ruler. Then we will add mass on both sides of pivot and balance the meter ruler. After it, we'll calculate the moment on each side by the formula moment is equals to force multiplied by perpendicular distance from the pivot. And if it is in equilibrium, the clockwise moment would be equal to the anti-clockwise moment. Next question. Figure 3.1 shows a side view of a part of concrete track at skateboard park. A skateboarder is initially at rest at point A. Then skateboarder travels through point B and comes to rest at point C. Describe the transfer of energy as the skateboarder travels from A to B to C along the concrete track. So firstly, this person is at point A, and you know this point has the maximum height from point B. So if it has maximum height, that means the potential energy at this point is maximum. Then the person start coming towards point B and the height start decreasing and the velocity of the skateboarder start increasing. At point B, the person has maximum value of velocity so that he has maximum kinetic energy. And where does this kinetic energy came from? All the potential energy is converted into kinetic energy. Then the person start moving up, height again started to increase, so kinetic energy is now again being converted into potential energy. So potential energy is maximum at this point and kinetic energy is minimum. So conversions of energy goes in a pattern that gravitational potential energy converts into kinetic energy. Then kinetic energy is again converted into gravitational potential energy. B part says B is at ground level and C is at 2.8 meter above the ground level. The mass of skateboarder is 65 kg. Calculate the work done on skateboarder as she travels from B to C. We have height, we have mass, and we need to get the work done. You know, work done is equals to energy supplied. Now, what is the energy supplied to the girl? From B to C, the girl is gaining gravitational potential energy. So, we'll calculate the value of gravitational potential energy to get the work done. And potential energy is mass times gravitational acceleration times height. Mass is 65, g is 9.8, and height is 2.8. So the answer for work done is 1800 joules. Second part says the skateboarder falls off the skateboard at B. She hits the track and comes to rest after few milliseconds. State the equation that defines the force F with which the skateboarder hits the track. State the meaning of any symbol that you use. So if the girl is hitting the ground and there is kind of collision, the momentum of the girl will change. So we'll have the change in momentum. We have provided the time as well, and we need to get the force. These three values are interconnected by the equation of impulse, which says that impulse is equal to change in momentum. If we want to get the force only, it would be force is equals to change in momentum divided by the time taken. So this is the equation, and delta P represents change in momentum and delta T represents time taken. Question number 4 says figure 4.1 shows a heater used to warm the air in the room. Part 1 says state the main method of thermal energy transfer throughout the air in the room. You know that if the heater is burning, the air above the heater will start getting warmer and the density of the air will start decreasing, and the air become less denser and the air rises above due to its density. Now the air above that is already cool and have greater density will come and fill the place, and then the heater will heat that air, and again the density will decrease and the air will rise, and from the above the cooler air will come and fill the place. This flow of air is known as convectional current. So answer to the first question is that air is warmed by the process of convection. Second part says explain how heater warms all the air in the room. So the explanation would be same. Heater warms the air above it and the density of air reduces and it rises. Cool air above with greater density will replace the area and falls down. This creates a cycle of convectional current. B part says the power of the heater is 2 kilowatt when it is connected to main supply with EMF of 230 watt. Show that the current in the heater is 8.7 amps. You know, power, voltage and current are connected by the equation power is equals to current times voltage. If we want to get the current, I'll rearrange the equation and it would be power divided by voltage. Power is 2000 watts and the voltage is 230 volts. Dividing these two together, the current would be 8.7 amps. Part number 2 says the plug connecting the heater to main supply is fitted with the fuse. Fuse ratings are 3, 5, 10 and 13 amps. State which fuse is used and explain your answer. The current needed by the heater is 8.7. That means we can use the fuse of 10 amperes. Now, why can't we use the lower values? Because the lower value fuses, if the higher amount of current is passing through them, the wire in the fuse can be blown out. And if we use the fuse with the higher value, for example 13 amps, what will happen that this can let more amount of current to pass through it, and eventually if the current increases by the value, this can damage the heater. So smaller rating can melt the fuse and larger rating can damage the heater. Question 5 says a ray of light is incident on a soap film. Figure 5.1 shows a magnified image of a small part of soap film. The ray of light is refracted as it enters the soap film. The refractive index is 1.28. Part number A says define refractive index in terms of speed of light. So it is ratio of speed of light in air to speed of light in soap film. B part says Show that the angle of refraction as light enters the soap film is approximately 43 degrees. We can use Snell's law for this. Refractive index is equals to sine of incident angle divided by sine of refracted angle. Now, if I want to calculate refracted angle, I will rearrange the equation and it would be like sine inverse bracket sine of incident angle divided by the refractive index of soap. Now, what is the incident angle? For this, we have to look this. So this is the incident ray and this is the normal, and normal is always 90 degree with the surface. So if this angle is 30, the above angle would be 60 degree because the angle between the normal and surface is 90, and out of 90, if 30 is there, then 60 would be above. So incident angle is 60 degree. Let me put the value over here. Sine of 60 degree divided by the refractive index of soap that is given by the question 1.28. Putting this into your calculator, the refracted angle would be 43.6 degree, which is close to 43. Second part says, carefully draw the refracted light in the soap film and label the angle of refraction. To draw the refracted angle, you'll bring your protector and place it on the interface and then align your protector perfectly with the normal, and after it you will measure this 43 degree from your protector and make a line at 43 degree. And now this angle is your angle of refraction, 43 degree from the normal. Now C part says the ray of light is monochromatic red light with wavelength 618 nanometer in air. First part says define monochromatic. The term mono means single and chromatic means color. So it is a light wave with single color, single wavelength or single frequency. Second part says calculate the frequency of the light. We can use wave equation for it. Velocity is equals to frequency multiplied by wavelength. So if I want to get frequency, it would be velocity or speed divided by wavelength. Now velocity of light is 3 into 10 raised to power 8 meter per second, and the wavelength given to us is in nanometer. Firstly, I'll put the value of nano, which is 10 in raised to power minus 9, and then I will put it into place of this lambda. So it would be 680 times 10 raised to power minus 9. Dividing both the values, the frequency would be 4.4 into 10 raised to power 14 hertz. Sixth question says figure 6.1 shows a person using a magnetic window cleaner. The part on outside of the window is attracted by the inside part of the window. Each part of the window cleaner contains two magnets. Figure 6.2 shows the magnetic field between two parts of window cleaner. So basically these are the two parts and between them there is a glass of the window, and these parts rub against that glass and cleans our window. And these are attracted by the magnetic fields of each other. Part A says glass is not a magnetic material. State the difference between magnetic and non-magnetic materials. So magnetic materials are material that experience force when they are placed in magnetic field, but non-magnetic material do not experience it. B part says suggest a suitable material for magnets in the window cleaner and explain your answer. We can use materials like steel because these are hard magnetic materials and are hard to demagnetize. C part says label the poles of the magnet in figure 6.2. Magnetic field lines exit from north pole and they enter the south pole of the magnet. So these are the north and south pole of the magnet. D part says state how the field lines show different strength of magnetic field between the magnets. Overall, the field lines are very close to each other, so magnetic field is very strong. But if we see the poles of the magnetic field is even more stronger in the poles. So what we can write is magnetic field is stronger near poles as the field lines are closest. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.